Okay, hi. These are the supplemental problems for section 6.7 in pre-algebra. Similar figures, proportional figures, whatever you want to think of it as. So definition of similar figures are two figures that have the same shape, but not necessarily the same size. Really what they are is just they're proportional. That's kind of the lazy way of talking about them. There's a symbol that we haven't talked about that really isn't something you'll need too much until later on or really in geometry. But it's a little tilde there from Spanish, if you took their tilde, whatever it is, if you took Spanish. And it means similar to. So it means these guys are similar. So all similar means is, again, they look the same except for one's a little smaller or a little bigger. The key to this section is actually representing and understanding these corresponding parts. And normally it's not too tough to see if they're oriented the same way, that angle A corresponds to angle E, B to F, C to G, D to H. You can just see they're in the same spot in the other figure. Same thing with the sides, AB to EF, BC to FG, DC to HG, and AD to EF. And what ends up happening is, if this is really a similar figure, they end up being proportional. So angle A to angle E equals angle B to angle F, and so on. And AB to EF for sides equals BC to FG. There's a corresponding ratio. So just like everything else we've done, we'll be drawing a lot of proportions. So again, they've kind of similar idea here with similar triangles. Technically, for similarity, it's two figures are similar when the corresponding angles are congruent. And the nice thing in this is, in this section, the book will mark those for us. Again, next at a couple years in geometry, it doesn't. We have a whole chapter about all this, but that again, that'll be 2 years from now. And then the corresponding sides are proportional and opposite corresponding angles. So that means they're, AB over XY equals BC over YZ, which is what we've got here. Okay. And then AC over XZ is the same as those. Okay. So basically what homework consists of is understanding the drawing and being able to set up a proportion and then solving that proportion. So let's take a look at an example. So here's number 6 from the homework. They want us to figure out the value of x in this drawing. What we really have to figure out is, what does x correspond to? And hopefully you can see, hey, it's between O and L. O has a triple marked angle, L has a single marked. Over here, J has a triple marked angle, F has a single mark. So that means that for this, this guy corresponds to this guy. Okay. So x corresponds to 12. Now, correspond to set up our proportion. So you can see O is triple angle, N is double angle, it's 15. J is triple angle, H is double angle, so it's 20. So 15 corresponds with 20. So all I'm going to do is set up a proportion for that. So I'll do, and I can do a couple different types, but I'll just do x over 12 equals 15 over 20. Because again, those are the guys that correspond. X corresponds to 12, 15 corresponds to 20. Oops. Give me a second to go. This is. Oh, I gotta draw. Sorry, excuse me. There we go. So, messing around with something I didn't really mess with. X over 12 equals 15 over 20. Oh, and sorry, what problem is that? That's problem number 6 from the homework. So number 6. Okay. So for me, I like to reduce these if I can. So 15 over 20, they're both divisible by 5. So x over 12 equals 3 over 4. And now we'll cross multiply. 4 times x, 3 times 12. 4x equals 36 then. Divide by 4. X is 9. So there's number 6. Okay, so let's see. Next problem. Number 8. Okay, number 8, yeah, number 8's a tricky one. We've got here that triangle A is similar to triangle B. So here's triangle A, here's triangle B. So do is I'll trace this. I think I can, yeah, do my triangles. Triangle, oops, not that one, that's isosceles. Here we go. It still doesn't want to do that way, okay. Alright, so we'll ignore that. So triangle A is similar to triangle B. Now, the key to this is the fact that they've marked up here that A is 20 across. I know it doesn't seem like it, but triangle A is actually 20 across for its base, and then it's 10 high for its height. So I'm going to do this. This makes this easier for me. I'm going to draw all four of those those two triangles, triangle A and triangle B. Even though they're not turned this way, I'm going to turn them myself on the paper. So A is 20 across. So here's triangle A. Okay, I'm going to make it 20 across here and 10 high. So there's triangle A, 20 across, 10 high. And it is inches, so I can go back to that. 20 inches, 10 inches. Now triangle B is 5 up and down. Again, it's turned up. It's been flipped from standing up to kind of standing down. But it's 5 inches over here. And then across its base, we don't know it's t inches. So that's what I'm looking for in the drawing. I know it looks like it says 10, but it's t inches. And I'll give a spacer so it doesn't look like it's saying tinches. But I know this isn't how it's drawn originally, but this is really how it's set up. If I put the right angle in the bottom left-hand corner, that's the setup. So 10, 12, 5, t. So that means that 10 corresponds to 5 and 20 corresponds to t. So 10 over 5 equals 20 over t. Again, reduce this. It makes it a lot easier. It's 2 and 1. Now I can cross multiply. 2 times t, 1 times 20. So 2t equals 20. Divide by 2. 10. And again, our units are inches. Do the same thing for B, and again, just to kind of keep this short, I'm going to skip that one. Leave that for you to do. Okay. Let's see. Last problem I want to look at then is number 12. Okay. Using a scale factor of 4/3, or 4 to 3 basically, draw and label a triangle similar to XYZ. Now, what that means for us is we say 4 to 3, 4 is the new, 3 is the drawing of the original one. So, I want to have a triangle that's similar to that guy that has a ratio of 4 to 3. So, I have XZ, and I'll just call this A, B, C for myself for the drawing. So if I look back at this, here it is, A, B, C. So, X corresponds to my point A, Z corresponds to B, Y corresponds to C. So I'll just sketch that out real quick too. X, Y, Z. And again, there's a right angle there. This is 6 and this is 12. And our units are inches. Okay. So, I'll go back to the drawing. And what I'm going to find is the two sides that correspond to the 6 and the 12 that fit the situation. So again, this is the new. This is the original. We'll call it ORI for original. So 4 over 3 is new to original. So 4 over 3 equals unknown, call this guy X, over its corresponding side, which is 6. So now I can cross multiply. 3x, 4 times 6. 3x is 24, divide by 3. X is 8. So this guy here would be then 8 inches. Okay. I'll call this guy Y, and we'll do the same thing this time with 4 over 3 equals new, which is Y, over old, which is 12. And then again, repeat the process. Cross multiply. 3 times y is 3y. 4 times 12 is 48. Divide by 3. Y is 16 inches. So this guy is 16 inches. And then that's the scale enough for us. Okay. 8 by 16. Okay, so that's section 6.7.